This is the solutions video for Growing Investigation 1 checkup. EE1. Make sure that you pause or rewind when needed. And if you have any questions after we're done, please see me before you try your retake. So number 1, Carmelita is planning to swim in a charity swim-a-thon, and several of her relatives said that they would sponsor her. So first, grandma, and they give you the table and want you to just fill in the donations up until 10 laps. So they give you 1 lap for $1, $3 for 2 laps, $5 for 3 laps, $7 for 4 laps, and then they want you to find the pattern and continue on until 10 laps. So we are not multiplying because 1 times 3 is 3 and 3 times 3 would be 9. So this must be addition. 1 plus 2, 3 plus 2, 5 plus 2. So we're just going to add 2. We get 9, 11, 13, 15, 17, and 19 for our first 10 laps. In number 2, these are from Dad. And again, we're filling in the ones that they give us. So $1 for 1 lap, $3 for 2, $9 for 3 laps, 27 for 4. So I'm going to look. If I add, I get 1 plus 2 is 3. 3 plus 2 is 5, not 9. So I'm going to multiply. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. And I'm just going to continue to multiply by 3. 27 times 3 is 81. Times 3 is 243. Times 3 is 729. 2187, 6561, and 19,683. I actually put my equation in there because we're going to come back to that a little bit further down the road. We'll use that equation. In number 3, they want to know about Aunt Josie. So she's given $2 for 1 lap, $3.50 for 2 laps, $5 for 3 laps. So filling this in, looking for my pattern, I see that this one is an addition pattern. And they want you to write an equation. So if it's addition, I know it's going to be linear. And a linear equation tells me that I need to find a constant rate of change and a beginning point. So you have to find y when x is 0. That's your starting value. So x is back 1 from 1, right? If I go backwards from here, I get to 0. And then my y, I'm going to go back $1.50. So instead of $2, I'm going to go back $1.50, ending on 50 cents. So when x is 0, y is 2 minus $1.50 or 50 cents. So my equation is going to be y equals 1.50 or $1.50x plus 50 cents. Number 4, we're talking about Uncle Sebastian now, who gives $1 for 1 lap, $2 for 2 laps, $4 for 3, and $8 for 4. I'm going to look for my pattern. I can add 1, but if I add 1 to 2, I don't get 4, so I'm going to multiply. 1 times 2, 2 times 2, 4 times 2. Telling me that my equation is going to be exponential with 2 as my base. So I'm going to put into my calculator, oops. I'm going to put into my calculator y equals 2 to the x. Clear these other ones out of there. And if I do second graph and look at my table, at 1, I should have 1. But in my calculator, it shows 2. and 4 and then 8. So I feel like I'm back 1, right? So let's check. Instead of 2 to the x, let's check 2 to the x minus 1. And again, second graph to get to my table. And now I have 1 at 1, 2 at 2, 3 at 4, 4 at 8, and it matches my table. So always remember, go in and check that table. You might have to subtract 1 or add 1 up here to your exponent. And number 5, they want to know how many laps would Carmelita need to swim to get $1 million from her father. So her father, back and find her father's, was this table here. And I have the equation, my donation is equal to 3 to the power of x minus 1. So I'm going to go to my calculator and put in 3 to the power of x minus 1. I equals, and instead of 2, I'm just going to change that to a 3. An arrow over. Second graph to get to my table. And they want to know when it will get to $1 million. So I'm going to just keep scrolling until my Y value is at least $1 million. Well, I see we're at 531,000 there. So at 14 laps, it puts her over $1 million at 1,594,000. So 13 laps is just under. Multiply that by 3 again, and you get over $1 million. So 14 laps. Number 6, they want to know how many laps would Carmelita have to do to get $1 million from Uncle Sebastian, and Uncle Sebastian's equation is D equals 2 to the x minus 1. So again, let's bring up your calculator. I'm going to again change that from a 3 to a 2. Let's arrow over. Second graph brings up my table. Again, I want this column. When this column is $1 million or more, that's your answer. So at 20, I can see we're already at 524,000. So when I double that, I'm just over $1 million at 21. So 20 laps, 524, 21 laps is 1,048,000. So 21 laps to get $1 million. Number 7, we need to write an equation to represent the following relationship. So we have 4, 16, 64, 256. I can see that we are multiplying by 4. 4 times 16, or 4 times 4 is 16, 16 times 4 is 64, and so on. So I'm going to start with 4 to the power of x on my calculator and see if it matches. Get rid of that minus 1. Second graph for your table. I better go back up to my 1. So 1 is 4, 2 is 16, 3 is 64. It matches. I don't have to do anything to my exponent for this one. Number 8, write an equation for this relationship. So again, the 1 is 25, 2 is 125, 3 is 625. So we are multiplying by 5 all the way up. So I know 5 to the x, but if I go into my calculator and put in 5 to the x, this one shows 1 is 5, 2 is 25, 3 is 125. So I feel like It's off by 1. And maybe if I add 1 to my x, so I'm going to go out here. And instead of just x, I'm going to do x plus 1. And look at my table, and this now matches. 1 is 25, 2 is 125, 3 is 625. So this one we needed to add 1 to that exponent. Number 9 wants to know when x is 10, what will the value be in our table? So we only went up to 6. So all I have to do is go back to my calculator and just look at what it is at 10. And it asks you to write it in standard form. So if I wrote it with the E or times 10 to the 7th, that wouldn't be correct. I need to write the standard form, which is shown down here, and that is 48,828,125. In number 10, they give you the graph, and you have to fill out a table to be able to come up with your equation. So I can't tell at 0 and 1 what those values are because they're just kind of estimated. But at 2, I can clearly see that we're at 9. This table is counting by 9s. And at 3, we are clearly at 27. So I can fill those in and then look for my pattern. And I see that we are multiplying by 3. So I'm going to open my calculator and I'm going to put in 3 for my base. I'm going to get rid of the plus 1 right now and just check this second graph. I have 1 is 3, 2 is 9, 3 is 27, and that starts to match. You can fill in those other, but they just wanted the equation. So you don't really need to fill in the table. You just need the equation, which is 3 to the power of x. 11 is write this in scientific notation. So we know each space that we move that decimal, we're going to have 1 power of 10. So our decimal number is 1, and we're multiplying it by 10 to the power of 7 because it's 7 hops to get to the end. 12, we have 6.157 for our decimal between 1 and 10. And then we need 1, 2, 3, 4, 5 hops to get to the end. So 6.157 times 10 to the 5th. 13, they give us scientific notation. We go back to standard notation. So they're telling me to move this 7 spaces to the right. So if I move at 1, 2, 3, 4, I'm at the end of the number. 3 more would get me 7. So I have to add 3 zeros to that. 64,501,000. And 14, 1 times 10 to the 12th. So your decimals right here, you need to add all 12 zeros. And some people got a little confused in their counting. So I would definitely put in those commas. Every 3 spaces needs a comma. So we have 3, 6, 9, and 12 zeros. 15, 7 times 7 times 7 times 7 times 7 times 7 is 7 used as a factor 6 times. Count them up. 16, 4 times 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 4 is 4 used as a factor 10 times. 17, what is the largest whole number value of n that your calculator will display in standard notation? So we don't want to use our table for this one. We want to go out to the regular screen of our calculator. So I'm going to hit second and quit. And I'm going to put in 5 raised to the power of, and then I'm just going to guess and check. You want to get to scientific notation and then go back 1, basically. So I'm going to guess 10. And we're not at scientific notation yet, so I'm going to guess a number bigger than 10. I'm going to go to 15. We are definitely at scientific notation here, so it's going to be between 10 and 15. So let's guess 12. No scientific notation yet. So let's guess 13. Still no scientific notation. Still no scientific notation. So it looks like 15 is going to be the first time that we get scientific notation. So what they want is the last whole number where it's displayed in standard notation, and that would be 14. In 18, they want to know the same thing, but with 16 as the base. Again, I'm going to put 16 as my base, and I'm just going to guess some numbers. I'm going to guess it's going to be lower than 15 this time. So let's start at maybe half of that at 7. Not scientific notation, so let's go 16 raised to the power of 8. 16 raised to the power of 9. At 9, we get scientific notation, so we go back up to that 8. That would be the last time in standard notation. So n would be 8. For 19, 20, and 21, they're asking you to write the number in exponential notation with either a base of 2, 3, 4, or 5. So I opened my calculator and I went to my y equals and I put in all 4 of these as bases. So in y2, I did 3 raised to the power of x. And then 4 raised to the power of x. The last one is 5 raised to the power of x. And then I went to my table, second graph, and I'm just looking for these numbers. So number 19 is 729. Remember, the first column is 2 to the power of x, 3, 4, and 5. So I'm looking for the number 729, and I see it right here. And that is my 3 to the power of, and I'm going to go over here, and I see that it's at 6. So 3 to the power of 6 would get me 729. Number 20 is 65,536. Again, I'm looking for that number in here. And I see it over here in the 2, 3, 4 column, 65,536, 4 to the 8th power. But if I scroll down, and I know some of you gave me this answer as well. If you scroll down in the 2 column, you also get it at 2 to the 16th power. So either of those are correct answers, 4 to the 8th power or 2 to the 16th. And finally, number 21, we're looking for 15,625. Looking for 15,625 right here at the top of my last column. So that was 5 as the base, and it's to the 6th power. 5 to the 6th power. Again, let me know if you have any questions, and good luck on your retake.